The goals of this video are to use congruent triangles and their congruent parts correctly and identify congruent triangles using side, 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 angle, side, angle, side, angle, 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 side, and right triangle, hypotenuse, leg. So first we need to figure out what congruent polygons are. So those are polygons with the same size and shape. Figures are congruent if one is a translation, rotation, or reflection of the other. So in this example here, we have triangle ABC is congruent to triangle XYZ because if we look at the angles and we look at the placement of the letters, so A and X are the first two letters, so they are going to be congruent to each other. B and Y are the second letter in each triangle, so those angles are going to be congruent. And then C and Z are the last letter in each triangle name. So all three of these triangles are going to be congruent, which means they're going to have the same angle measurement. The same thing is true for segments. So the first two letters AB is going to be congruent to the first two letters of the other triangle, XY, which forms segment XY. Then we have the second and third letter, BC and YZ are congruent. And then lastly, we have the first and last letter, which form the third segments that are congruent. So as you can see, the location matters. So when we're saying that ABC maps onto XYZ, we're saying that the following vertices and segments match up. So we are saying that angle A matches with angle X, angle B matches with angle Y, and angle C matches with angle Z. If you look at their names, we notice that A and X are the first letter, B and Y are the second letter, C and Z are the third letter. Then when we go to segments, segment AB is going to match with segment XY, they're the first two letters. Segment BC is going to match with YZ, they're the second and third letter. And then we have CA is going to be congruent to ZX because it's the third letter and the first letter. These angles and segments that match up, or sides, are called corresponding sides and corresponding angles. If two figures are congruent, then their corresponding sides and corresponding angles must be congruent. So let's complete the congruency statement. So we have triangle DVL is congruent to triangle CUB. So we need to help with the names to help us match up correctly. Because as we notice, one is a reflection of the other because it's flipped down. So angle C is the first letter in the second triangle. It's going to match with angle D, the first letter of the first triangle. Angle LDV is going to be congruent to angle. Now we need to use three letters. So L is the third letter, it matches with B. D is the first letter, it matches with C. And V is the second letter, which matches with U. So we would have it congruent to angle BCU. Then we have segment CB. So segment CB is the first and last letter. So in our other triangle, we would have DL. Segment LV is the third and second letter, so that would be with segment BU. And then we can also rename our triangle. So instead of triangle cub, it was reversed to become triangle BUC. So we can reverse the first triangle, so it's LVD. In number 2, we're not provided a picture, which is okay. We can just use our letters. If you're somebody who's a visual person who likes to see the triangles, you can always redraw them. So I can name the first triangle red. I'm going to draw the second triangle, and I know that Y must be in the same place as R, L must be in the same place as E, and W must be in the same place as D. So when we look at our names of our triangle, or we look at the pictures, WY is the third and first letter, so it must match with DR. LW, segment LW, is the second and third letter, So we need the second and third letter of the other triangle, ED. Then we have angle DER. So triangle DER or angle DER is going to match with WLY. We just are reversing both names. Angle W is the third letter, so it's going to match up with angle D. And then triangle DER. So D is the third letter that matches with W. R is the first letter, which matches with Y. And E was the second letter, which matches with L. So in number 3, we have triangle rat is congruent to triangle dog. Solve for X and Y. So I want to set up two triangles, so I'm going to draw them looking the same orientation. So we have triangle RAT, and we have triangle DOG. When we label our sides, RA is going to be 23, OG is 29, AT is 2x plus y, angle T is 5x plus 2y, angle G is 64, and angle O is 72. So if we are looking for an equation to set up, I want a corresponding angle or corresponding side that can be congruent to each other. So angle T and angle G are both angles. They are going to be congruent. They're both the third letter of each name. So 5x plus 2y is going to equal 64. Then we have AT, which is the second and third letter, and OG, which is the second and third letter that match up. So we would have 2x plus y is equal to 29. So in order to solve a system, we need to multiply one of our equations. So I'm going to multiply the second equation by -2. So I get 5x plus 2y equals 64, and I get -4x minus 2y is equal to -58. When we add our equations straight down, the y's cancel out, so x is equal to 6. And then we can substitute back in to get x. So we would have 2 times 6 plus y equals 29. 12 plus y is equal to 29. We can subtract 12. So we get y is 17. So we would have 17, 6. So the rest of this lesson, we are going to talk about proving triangles are congruent. So there are 5 methods to prove triangles are congruent. The first method is side, side, side. So in side, 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 if all 3 triangles of corresponding sides are congruent, then the 2 triangles are congruent. So for example, if A, B, and DE are congruent, if B, C, and EF are congruent, and A, C, and DF are congruent, they're all going to have the same tick marks. They're going to have 3 different sets of them. So we would have triangle ABC is congruent to triangle DEF by side, side, side. So the 3 S's stand for all of the sides. So in number 2, we have side angle side. So there are 2 S's representing sides, and there is an A representing angles. So if 2 sets of corresponding sides and their included angles, okay, and included angles is important, are congruent, then the 2 triangles are congruent. So if we mark 2 sides, AB is congruent to DE, and AC is congruent to DF. The included angle is going to be the angle that is formed by both sides. So in this case, it's going to be angle A and angle D. So we would have triangle ABC is congruent to triangle DEF by side angle side. In angle side angle, now there's going to be 2 angles and 1 S. Notice that the S is in between the 2 angles. So in this case, if a set of corresponding angles and their included sides are congruent, then the 2 triangles are congruent. So this time, if I pick 2 angles and I say B is congruent to E and C is congruent to F, the included side is the side that's formed by the 2 letters from those angles. So we would need BC to be congruent to EF. Then we could say triangle ABC is congruent to triangle DEF by angle side angle. Now, notice angle angle side also has 2 A's and S, but this time the side is outside of the two angles. So for this case, let's use our same angles we used in the triangle above. So we're still going to say B and E are congruent and C and F are congruent. So a non-included side is one of the sides that is not formed by B, C, and E, F. So we can pick either side. The side should only be touching one of the angles though. So we could say AB is congruent to DE. That would say triangle ABC is congruent to triangle DEF by angle, angle, side. Our last method then is a special case because it only works in right triangles. So hypotenuse leg, which sometimes is just called HL and other times called RHL, is when you have two right triangles and you have a leg and a hypotenuse that are congruent. So we notice right now we already have the right angles measured. One or marked. One of the legs is going to be one of the sides that is forming that right angle. So here's a leg and a leg. And then the hypotenuse is the side that's across from the right angle. If you have those three things, then we can say triangle JKL is congruent to triangle PQR by RHL. If you call it HL, that's fine too. So one more property before we start using these is reflexive property. Reflexive property is an angle or side is congruent to itself. For now, what we're going to use reflexive property for is if we have a problem with a shared side. So in this case, we have a triangle on the right and left. BD is a side that is forming both triangles, so it would be congruent. We could say BD is congruent to BD. We can also use this for angles, but we'll get to that later when we get to similar triangles next semester. So in number 4, we already have two sets of sides that are congruent because AC and SC have the same marking and AR and SR have the same marking. Also notice though that between these two triangles there is a shared side CR, so we could also mark CR is congruent to itself. So now we have three sets of information. So in this case, we have all three sets of sides are congruent. So this method would be side, side, side. When we go to name our triangles, we have to be careful about how they match up. So CA is the side with two dots. So that would be congruent to CS. And then we put our last letter of R. In number 5, we have a triangle that has GF congruent to LF already marked. We have one right angle, which means on the other side of that line, it also has to be a right angle. So right now we have two pieces of information. We have one sets of sides and one sets of angles that are congruent. Again, we have a shared side of OF, so we can also mark OF congruent to itself again using reflexive property. So we now have our three pieces. So in this case, we would have side, angle, side because both of these sides are forming this angle. So our method is side, angle, side. So triangle GOF is congruent to triangle LOF. In number 6, we can't use reflexive property because we don't have any shared sides, but we do have vertical angles. So if this is a right angle, this is also a right angle. So now I have to decide, is this going to be side angle side or is this going to be something else? So side angle side, remember, has to have the angle between the sides, which this is not. So my only saving grace is, do I have a right triangle? Which I do. So this would be my leg and this would be my hypotenuse. Remember, you can only use RHL if it's a right triangle. So this is RHL or HL is fine. So triangle DNA is congruent to CNE. Number 7, we have two triangles that are overlapping. So if we look at these two triangles, we have the first triangle. That's a right triangle, so I want to draw it so I include that right angle. And then I have GOR. If you notice that the triangles are overlapping, you can see with the highlighting that they changed color where they were overlapping. So we can use reflexive property for segment RO. So in this case, though, just because it's a right angle, we would not just call it RHL. In this case, and if it helps me to redraw my triangle, I have FRO. So I have FR is marked, RO is marked, and the right angle is between them. So this would be a side angle side. Now, because the triangles aren't named, we can name them either way. So I'm going to name triangle FRO is congruent to triangle GOR. In this case, O and R are different angles, right? In the yellow triangle, R is representing a right angle, but in the blue triangle, R is representing a smaller angle. In number 8, we have two angles that are marked congruent. We also have two right angles. So we now have two sets of congruent angles. Again, we have this shared side to use reflexive property. So we can mark that side congruent as well. So this case, we have two angles with the included side. So this is going to be angle, side, angle. Triangle CAE is congruent to triangle KAE. In number 9, we have a shared side, MT. We also have two sets of angles that are already marked congruent. A is congruent to H, and then the T's from both triangles are marked congruent. We can also mark our shared side congruent. This time, the side is not between the angles because it's not over on this side formed by both angles. So this is going to be angle side. And we would say triangle MAT is congruent to triangle MHT. In number 10, what additional information is needed to prove triangle MON is congruent to triangle STR by the given method? So when I look at my triangle, I want to know I have two pieces right now. I need a third to use that method. So remember that HL we can also call RHL. Well, we already have a right angle, and OM and TS are representing the leg. So we would need the hypotenuses to be congruent, and the hypotenuses are the side across from the right angle. So we would need ON to be congruent to TR. In our next method, side, angle, side, we have a side, we have an angle, we need the other side that is touching those angles. So that is going to be MN and ST. Sorry, SR. So MN and SR. Then we have angle, side, angle. So we have an angle, we have the side that is touching, we need the other angle that's also touching that side, which is at the top of both triangles. So angle O is congruent to angle T. In the next one, we have angle, angle, side. So in this case, we want one angle that's away from the side. Well, we already have the side and the angle touching the side because the right angle is formed by these congruent sides. So we need the angle that's away from the side. So you can think about it as the angle opposite of the side. So we would need angle N is congruent to angle R. In number 11, what additional information is needed to prove triangle FIH is congruent to triangle SIH? Well, they have a shared side, so we can mark that congruent with reflexive property. So if we are doing side, angle, side, we have our two sides. We need the angle that they are forming. So if I trace these sides, I notice that they are meeting up here. So those angles, we can't just call them angle I because there's too many vertices. So we're going to name them with 3 letters. So angle FIH has to be congruent to angle SIH. In our last question, side, 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 we have two sets of sides. So we need the third set of sides to be congruent. So FH would have to be congruent to SH.